Okay, everybody, here we go. So, with this idea of the mole, okay, first thing we need to understand, once again, what it is, like Blake reminded us in the warm-up, it's a counting number. Okay, that's all it is. It's a really, really big counting number, but that's what a mole is, right? When I say I have a mole of something, I have 6.02 times 10 to the 23rd of that thing, right? Just like if I were to say I have a dozen penguins, how many penguins do I have?
12.
I have 12. Well, a dozen, because that you just know, right? If I have a mole of penguins, how many penguins do I have? 6.02 times 10 to the 3rd, right? Our Earth would be taken over by penguins. Okay? But that's all it is. It's a really, really big counting number because atoms are really, really small. So we need it to make it work. It's also known as Avogadro's number because he's the one who proposed that idea. Okay? Just a few other examples of how big it is. And talk about the basketball one. This mole of pennies idea is like crazy to me, right? The video talked about if you got a mole of pennies the day you were born, you could spend $1 million a second until the age of 100, and you'd still have 99.99% of your money. That's how friggin' big a mole is.
Every second of your life.
Every second of your life, $1 million. Can you help us recognize this? We can't count a mole out, right? I can't go 1, 2 because I die before that happens. So the indirect way in which we can measure a mole is through what is known as the molar mass. And this is what was on your introduction assignment. Okay, a molar mass is found on the periodic table. When I look on the periodic table, let's say like for carbon, this number on the bottom is known as the atomic mass. But it's proportional to the molar mass. So an atom of carbon is 12.01 AMUs, because that's the unit for a single atom, but a mole of carbon is 12.01 grams. Okay, so this molar mass is proportionate to the atomic mass, and we find it simply on the periodic table. Okay? The way that we're going to do it is I want you to keep 2 decimal places. Just out of formality, because depending on what periodic table you look at, sometimes it has more or less decimal places. So we're just going to always round to 2 every single time, so that hopefully we're all the same.
Just ignoring sig figs then?
Well, you're going to always round, right? You want to round it, don't just take 2. But we're going to round it to 2 sig figs, and then those are our sig figs. Yeah?
So, like, would you round it, like, before you take the numbers and add them?
Oh, okay, so like in a calculation, I would, because then my numbers are simpler.
Okay.
But technically, if you didn't want to round them and then round at the end, it should still work out the same. So, good question,
So you
Tyler.
can just round at the beginning and not round at the end? Or do you have
That's fine too, yeah. If you round at the beginning, then it should work out too.
Oh, wow.
Okay? So, for example, if I wanted to find the molar mass of an element, Blake,
Look at the bottom.
we just look at the bottom of the periodic table, right? So this would be a good idea, everybody. Pull out your periodic table right now and have it in front of you. Okay, write down aluminum and zincs for me. Write down the molar mass of both of these, and then if you get them right, I'll give you a smiley face.
Jamie,
Yeah.
do you put grams per mole or just grams on these?
Grams per mole.
When you
put 'em-
say you want there to be 2 answers to decimal places, do you mean there has to be at least 2, or if there are more than 2, just write it as 2?
Write them as 2. Yeah, if there's more than 2, write it as 2. All right, everyone, turn back up front here. Check your work with me. So aluminum, you should have, what am I doing? 26.98 grams per mole are your units. It's a 2-unit answer. It's not just grams. It's that's how many grams there are in 1 mole of aluminum. Okay, for zinc, you should have 63.39 grams per mole. Okay, questions on these?
65.
65.
That's what I meant.
Yeah, that's confused.
Sometimes my brain gets ahead of myself. Like I go too quickly, so I knew that. Anyways, 65.39 is what you should have. Okay? So this is how we find the molar mass of a single element. The next thing we need to understand is how to find the molar mass of a compound or a molecule. Okay? So for example, if I wanted to find the molar mass of water, the first thing you have to have is the formula. Good. And if your formula is incorrect, everything else is going to be wrong. So knowing how to do formulas is going to be key. The next thing we do is we break it down and say, okay, well, let's find hydrogen. Looking on your paper, I see that the molar mass of hydrogen to 2 decimals is 1.01. Okay, yeah, Blake.
Okay, I'm always confused about the little number.
Okay, so what does this little 2 mean?
Well, like, I know it's like 2 oxygen, right? Or is that 2 hydrogen?
This 2, right, it goes to the one that's to the left of the number. So it means there's 2 hydrogens.
But I thought it meant the Mickey Mouse ears, that's why they were O's.
Next to. Okay, so we're going to take this number, everybody, times it by 2, and then oxygen, that one will round to just 16.00. How many oxygens do I have?
One.
Just 1, so I don't have to times it by anything. Then you want to add them together, 18.02 grams per mole is your final answer. Okay? And that's okay, because that, once again, is to introduce us, and if anything, make mistakes then so we learn from them today. Okay, sodium chloride. Once again, the key thing is writing the formula. If you don't write the formula correctly, the rest of it's going to be wrong. So find sodium on your periodic table. What's its symbol? Na. What is, don't say it out loud, but show me on your fingers, what's the charge for sodium? Because we have to check the charges. 1, +1, because it's in the first column. All right, chloride is Cl, and what is its charge?
Wait.
-1.
-1, right? Because it has 7, so it's going to gain 1. Since it's 1 and 1, do I have to do anything?
No.
In this case, I don't. But you have to check the charges, okay? If you struggled in Unit 2, okay, and you still struggle with formulas and charges, come see me, because it's not going to go away. We're going to be writing formulas the entire year, and you're only going to make it harder on yourself if you try to ignore the problem. Okay, so come see me if you still don't know how to do that. All right, so here's our formula. So now I find the mass of each. So sodium has a mass of 22.99. Chlorine has a mass of 35.45. And then we add them up together to get
Wait,
56.
are you not rounding for sodium?
I did round for sodium.
50.
Because on my paper it's 22.989. See that?
58.
It should be 58.44.
Oh, sorry. Thank you. 58. Thank you. And what are my units?
Grams per mole.
Grams per mole. Yeah, Blake. Okay, let's try a few more. If you feel really good about it, go ahead and try the next 2 on your own. If not, actually wait, before you start on your own, let's do the symbol together, because that's where most people were messing up last period. So I'm not going to go to the next slide because I accidentally gave you the answers too early. Okay, but what is it? Sodium carbonate?
Sodium carbonate.
Okay, so it tells us sodium carbonate, and we want to know the molar mass. So once again, what's the symbol for sodium? Okay, and good, put the plus. Where do I find carbonate?
On the back.
Good, so flip to the back side, what's carbonate?
CO3. 2 negative.
Good, so then, what happens to the charges? Crisscross, so your answer should be Na2CO3. If you don't get this right, your molar mass will be wrong too. Does everyone see how we went from here to here?
So that just means it has 3 of them, or like 3.
So then, just start with Na. So Na we know is 22.99. Since there's a little 2 here, what does that mean?
There's 2.
Times it by 2. Okay, how many carbons do I have in this formula?
3.
Is the 3 touching the carbon?
No. Or it's not touching the oxygen.
It's only touching the oxygen, so I just have 1 carbon. But then for oxygen, I have 3 of them. So I'll times that one by 3, and then we'll add them all up. Okay, try sucrose for me, which the formula...
Wait, we never figured it out.
Oh. What do we have for our answer?
105.9.
That sounds about right. 105.98? 99?
Wait,
Yeah, that
why
sounds
are we
right.
doing 99? Why not?
I think, what's the number after? Or is yours just 8? I think you might have missed a decimal.
So then what would have happened if you had to have the parentheses? Oh!
So, if we'll get to one of those here in a second, but that's a good question. Okay, sucrose, the next one. Sucrose has the formula of C12H22O11.
Oh.
Calculate that for me. Hey,
More math.
why are you giving me this? All you're going to do is you're going to push the buttons on your
You
calculator.
write it down.
Yeah, but then you make
It's not like I'm making you do it in your brain. It's not that bad.
What was it?
So this is sucrose. Okay, so write that down on that second one. Find an answer for me, and if you get it right, you can have a smiley face. Okay, on the count of 3, you're going to shout out your answer, and we'll see if we all match.
Oh no.
Ready? 1, 2, 3.
342.34.
I think I heard it. 342.34 is what you should have. You got that right, you can have a smiley face. Okay, here's an important question. Come back up front. If you didn't get this, do you know why?
No.
Okay, you should have taken 12 times 12.01. Because that's carbon. 22 times 1.01, because that's hydrogen. 11 times 16, and then add them all up. So if you did that and you just got the wrong answer, I'm guessing just mathematically you typed it. 343. Are your numbers just like this? Or did you round it?
15.99 for.
Oh, okay, so yeah, so that does show you if you round it slightly off, because technically oxygen is 15.999. So since I'm rounding it to 2, you would round it up. But being that most of the time it's multiple choice, you would be close enough that you would know which one is correct still, because you know
It's rounded upon.
So say that again.
So I write it until the I say we're running to the end of it,
Uh-huh.
but it also would still be right, or would it?
Yeah, because because you're going to show me your work anyways, right? So if I can see your work and I see that you waited to round till the end, and so your decimal, what did you get for your answer, Brock?
I got 342.30.
Okay, yeah, so if your decimal is slightly off because of that reason, that's fine. So, yeah. Okay, so here's the last part of what we need to learn. Okay, so what we're going to be doing now with moles is conversions. Since molar mass is a grams to mole ratio, it can be used to convert between those 2 units. Okay, just like with density, we're going to follow the same pattern. Okay, so what I need from everybody today is this. Once again, for some of you, conversions may make a lot of sense, and they're really quick, and that's awesome. For others, it may take a little bit more practice. Either way, I need everybody to follow and write down step by step what we're doing. Because the process of doing that is going to help you either way. No matter if you understand it or not, it's going to make sure we're all on the right track, okay? So the first type of conversion is between grams and moles, or moles and grams. We can go either way. Our connecting piece, so write this in the middle above the arrow, is the molar mass. That's what connects us between them because it's grams per mole. So if I'm given grams and I want to get to moles, or if I'm given moles and I want to go to grams, we're going to use that molar mass. So for example, for carbon, it's 12.01 grams in 1 mole. Or just like with density, we can flip it, and it's 1 mole in 12.01 grams. Conversion factors can be flipped all we want, but notice that the 12 is always next to the grams.
As in 1 mole of carbon?
Yeah. So if I had 1 mole of carbon in my hand, it would weigh 12.01 grams.
So tiny.
Okay? So tiny.
So is that just the molar mass though, which is why we know it?
Yes, that's why you had to learn molar mass first. Okay? All right, so let's try this problem here. So how many moles? So everybody circle moles in the question. That is the goal, right? Always circle what we're trying to find. So circle that word moles. How many moles of carbon are in 26 grams of carbon? Underline this. 26 grams. Circle what we're trying to find. Underline what we know. We always start with what we have underlined. So start with 26 grams of carbon. So write that down. 26 grams of carbon is what we know.
And then grams go on the bottom.
Good. Why do grams go on the bottom?
Because they have the same number.
Because we always want to cancel, right? Copy, paste. I'm waiting for the day when I can do that in real life all the time. Copy,
And
paste.
we're closer to those hovering chairs in Wally with the cardboard, so we'll get
I think so. Okay. Grams of carbon go on the bottom. What's going to go on top?
1 mole.
Moles, because that's what I'm trying to find. Fun fact, you can abbreviate the word mole by taking away the E. That's acceptable abbreviation. Why they need to abbreviate a 4-letter word to a 3-letter word, I don't really know. But you can do that.
It's 1 letter easier.
So don't be like, oh, you spelled mole wrong. No, I'm abbreviating it. Okay?
At first I thought it said mole.
All right, don't say anything, but point with your finger. Where do I look to find the number to plug in here? Where do I find that number? Point with your finger. There's a magical, I guess there's more than one place you could be pointing. The periodic table, right? So you're either pointing there or the one on your paper.
Works too.
Okay? Or I guess we already found carbons, right?
Yeah.
So the molar mass of carbon is 12.01. This comes from the periodic table.
Or your yellow paper.
What?
Or your yellow paper.
Or it's on your paper, but that originally came. And how many moles is this equal to?
1.
Just 1. Because that's what it means by molar mass. Then, since it's on the bottom, what do I do mathematically?
Divide 26 by 2.
So 26 divided by 12.01 because it's on the bottom. And after sig figs, we get an answer of 2.2 moles.
Yeah. Oh, yeah.
Yeah.
Why?
Because it would just be, that means we have 0.2 of 6.02 times 10 to the
Do
23rd.
we need C?
So 1 mole is 6.02.
Yep. Yeah,
Do
bro.
we always do we always need to put down like the letter of the element?
Ooh, that's a great question. Everyone look up here at this. Look up here. So Brock asked, do I have to put this letter? And the answer is yeah, because you can have moles of anything, right? We can have moles of penguins. So we need to signify what it is that we measured. So yeah, you do have to put that. Good question, Brock.
Wait, is there a set? So how many moles of people are there out
You can't really have. Say that again.
there? How many moles of people are there out there?
Does not.
If you're feeling really good, try it on your own. If not, follow along with me once again. Okay? First thing you want to do is circle what you're trying to find,
Moles.
which is moles again, right? Circle that in the question. Okay? I know I have 37 grams of H2O.
Yeah.
Since grams is here,
It goes on the bottom.
copy paste to the bottom. I'm trying to find moles because that's what I circled. How many grams of water are in a mole? Well, we already solved it. How conveniently, we already solved it. It's 18.02
Oh wait, but that's really annoying. Does that mean now whenever we get a compound, we have to solve for it?
Yes.
Oh.
So you're going to get really good at finding molar masses. And I bet by default, you'll start memorizing some of them, like water, because we'll use it so much. Okay?
Would it be 1 mole? Because we solved it up here.
So that's the molar mass when we added up the mass of water. That's where it came from. All right. After math, you should get a final answer of 2.1 moles of water. Okay. All right, everyone, focus back up front. Okay. All right, next step. So we did grams to moles and moles to grams. Now we can do moles to particles. Because how many particles are in a mole? 6.02 times 10 to the 23rd. So write that above that arrow.
Wait, how do you know that?
Because by definition, that's what a mole is, right? That's how many things.
I thought the 6.02 was 1 mole though.
So 1 mole equals 6.02 times 10 to the 23 of something. It can be really anything, right? Because it's just a counting number. Okay, also known as Avogadro's number. So we could write them as a conversion in 2 ways. 6.02 times 10 to the 23rd per mole, or 1 mole is 6.02 times 10 to the 23rd. Right? Conversion factors can always be flip-flopped because they're equivalent to each other. Okay? One thing we need to understand about particles is a particle can represent a variety of things, like we mentioned, because simply it's a counting number. That's all that 6.02 times 10 to 23 is. Right? It's a really, really big counting number. So when you hear the word particle, or all the different times you could use this number are with atoms, with molecules, formula units, ions, electrons. Any of these options, we can use that Avogadro's number. Okay, any of the options will use this number. Okay, atoms, molecules, formula units, ions, electrons, people, whatever we want to calculate. Ramen noodles.
Rice grains. That, I bet there's a mole of rice.
Rice grains? Yeah. That would be interesting.
I don't think so.
How would you find them? Okay, let's try this one.
Probably been a mole.
Okay, everyone circle in this problem. What are we trying to find? Now we're trying to find molecules. Okay? Hey, breathe everybody, it's gonna be fine. Okay, we're starting with moles.
We're starting with moles.
And hey, we found out on the back.
C12, 822, 011. All right, I need a little bit more focus from everybody. Okay, if you feel pro, move on your own, but don't distract those around you who I can guarantee some may need more help.
Is that something you've used this number? You've used this formula twice?
Yes, so I saved us a step here. So we go, what's going to go on the bottom?
Mole.
Moles, because we wanted to cancel. And then what am I trying to find now?
Molecule. Right?
Oh, I guess we won't use that yet. But we will be using that molar mass later. But since I'm going to molecules, so notice I know it's silly, but it's just the way it is. You can abbreviate molecule because then it looks like mole. Why they chose to abbreviate the 4-letter word instead of the longer word, I don't know. But that's just how it is. So don't blame me because I didn't choose that. For molecules, or what is it?
Is it the car?
Look at the boxes right above. It's that 6.02
Why?
times 10 to the 23rd.
Why?
Because that's how many molecules are in a mole, right? Remember, conversion factor is equivalency.
I thought that would call particle.
Remember how just above it on the previous slide, we said that a particle could be any one of those things. Right? So any one of those are acceptable. Okay? All right, when you plug this into your calculator, you could use the shortcut of E, right, if you wanted. So I would do, this is how I would type it in, 2.50 times 6.02 e to the 23rd. Or you can type it in the long way. Either is acceptable.
23 zeros.
Does it make sense that it's a big number? Yeah. So you should have gotten 1.51 times 10 to the 24 molecules of sucrose. Or C12H22O11. If you feel good, try setting this one up on your own. Okay? Go for it now. Try setting it up on your own. And then we'll go over all together here in a second.
8.9 moles of no-show.
That's baking soda, by the way. Sodium bicarbonate.
Does that say 3?
CO3?
Yes, CO3.
Yeah, CO3. Okay, try this one on your own. You should be no talking. Your eyes are on your own paper and you're trying it out.
So, would we say, for our ed, would we say that number?
How many formulas?
Yeah. So that's, yep, you'd say formula units.
What?
Remember? Because it's just the same thing as particles.
Basically just
Here's
how
what I'll
many
do.
objects slash one.
Not molecules.
Abbreviation for.
Yeah, don't abbreviate formula units.
Oh, I get it.
Yeah, I was just saying that for fun.
Yeah, no, I didn't know why you were saying F.
Okay, I'm going to do a mistake up here on the board.
No, wait, no, don't do that.
Okay? And don't say it out loud, but if you know what mistake I make, raise your hand.
No mistake.
Bam, first hand up.
Don't say it out loud, but just raise your hand if you know what I did wrong. It's just wrong. All of it.
Just know it's wrong.
Well, I told you it was wrong, but you need to tell me why it's wrong.
That was right there.
Okay, everyone, let's listen to Jenna. Yeah, didn't you have your little window? What did I do wrong, Jenna?
You put it on the bottom instead of on the top.
Good. Okay, remember that this should make sense. This doesn't make sense. You're saying that in one formula unit, there's that many moles? That's like a mole of moles.
That's wrong.
Whoa. Too big.
Oh snap. Are you full square?
Oh my gosh. That's too many.
Okay, times it through, and you should have gotten an answer of 5.36 times 10 to 24. Yay! Okay, questions?
Can we use smiling face if we thought it was that wrong thing?
Yes, if you caught my mistake, have a smiley face. So the last thing we need to learn today, sorry my camera died during class, so we're going to have to do the last part this way. So we did an example where we had grams and we went to moles, and we used the molar mass to help us find that, which is grams per mole. And then we also did examples where we did moles to particles, and for that example we then use Avogadro's number, which is particles to mole relationship. So the last piece that we're going to do is when we connect all three, the key thing to recognize here is you can't go from here, too far. Okay, you can't go from grams to particles. You have to go to moles first. That's key. Okay, you have to go to the moles. And in doing so, then we can do a two-step process to get us to where we need. So let's do an example problem. Let's ignore this. Okay, so we're going to use this as our guide of where we're going. So the first thing, like we did before, is in your problem is to circle what it is that I'm trying to find. So I'm trying to find mass, So I want to circle that. And then I underline what I know, and what I know is what we then start with. So we start with 2.10 times 10 to the 24 particles. Okay, so notice according to our map up here, we're at particles, and we want to get to mass, and so we're going to have to go to moles and then to mass. So the step between there is Avogadro's number. So your next step is particles go on the bottom because we want that to cancel, and then moles go on top. Now that we're to our mole relationship, our bridge says, well, to get from moles to mass, we use the molar mass. Once again, since moles is here, we want to put it on the bottom of the next step. And then grams is what goes on top, and this 84.10 is the molar mass of our sodium bicarbonate. So if you don't know the molar mass of what you're working with, you will have to calculate that like we learned in the beginning of the lesson today. A good way to know if you're doing everything right is everything should cancel except for what I'm trying to find. And then when you plug it into your calculator, remember it's anything on top, so you would do this. Divide by that, make sure you put it in parentheses, times by our 84.1. And after sig figs, because we only get 3, you get an answer of 293 grams of NaHCO3. All right, let's try another one. So once again, we're trying to find mass, and we start with molecules. So in the beginning, if you are confused a little bit, don't be afraid to use that roadmap of those boxes like on the last slide, because they will guide you in where you need to go. So once again, we start with what we know. So we know that we have 4.45 times 1025 molecules. Since molecules is here, molecules goes there. We have to go to moles first. Make sure those cancel. Then from moles, we can then go from moles to grams. Once again, the grams is the molar mass, which we find by adding up 1 carbon and 2 oxygens on the periodic table. When you plug it all in, you should get an answer of 3,250 grams of CO2. What you're going to do now is the sub will pass out to you a handout for your assignment that will help practice some of these 1-step and 2-step ones. Okay, do the best that you can on it. It is due next time. We'll definitely answer questions on it, but I want you to have completed every problem before next time so that we know what question you have. Okay, good luck.